All right, start. Uh, okay, where's this? Yeah, okay. Section 14.6, change of coordinates in triple integrals. So this is again something similar to what we have done in double integrals. Let me just remind you what we had done yesterday for double integrals. Okay, so let's say we had something like this in the xy plane, and we want to change x and y to new coordinates u and v. Okay, u and v. And what we had done, we pick a point x0, y0, and then we move in the x direction a little bit and y direction a little bit. We form this rectangle whose area is delta x times delta y. And this is transformed via this coordinate change to the UV plane. How? This vector delta x is mapped to this vector A, and delta y is mapped to the vector B. How? Well, like this. You see, when you change x0 a little bit and in U and V, what happens? You obtain this, right? This is first order approximation, tangent plane approximation to the function. This was your exam question, right? The last question. So if you increase delta x a little bit, U and V are increased this much. So that's the vector A. And if you increase the y coordinate a little bit, so this increment gives you the vector B. So what happens is this. If you increase x and y a little bit, this point is moved to this point, and this rectangle is moved into this parallelogram. And the area of this rectangle is changed how much? Well, this had area delta x delta y. What about the area of this? We computed that area. It turned out to be just this expression, which is a determinant of first order, first degree derivatives times delta x delta y. So this area is multiplied with this determinant, which we call Jacobian, right? Jacobian. We call that expression. So this is called the Jacobian. Okay. Yeah, Erdoğan'a Jacobian demiştik. So in several variables, in three variables, we do the same thing. Okay. So let me just repeat what we have done. So this time we have x as a function of UVW, y as a function of UVW, and z is a function of UVW. And then we have this volume element, which is dx, dy, dz. And uh, the okay, so uh, bu benim anlattığım gibi anlatmıyor tabii de. Ben böyle yapmamıştım değil mi? Biz x'i e, u'la yok. U'la v'yi x, y cinsinden yazdık. Değil mi? Öyle yaptıydık. U'la v'yi x, y cinsinden yazarak yaptık. Evet. Tamam. Yani aynı şey tabii de. Şöyle diyeyim ama. Yani suppose we are at a point x0, y0, z0 and we have this box. Okay. So this is the point x0, y0, z0. I move a little bit in the x direction, a little bit in the y direction, and a little bit in the z direction. So u as a function of x, y, z, v as a function of x, y, z, and w as a function of x, y, z. Uh, this point x0, y0, z0 is moved to this point. Let's say u0, v0, w0. And then these vectors, delta x, delta y, delta z, are moved to these three vectors. Let's say a, and then b, and then let's say c. Okay, and this form a parallel pipette in the UVW plane. How? Something like this. And then, okay, so something like this. What are these vectors A, B, C? I can write those vectors using tangent plane approximation again. But this time actually we have three variables, but doesn't matter. So u okay, x plus delta x, y plus delta y, and sorry, z plus delta y, delta z. What is this? This is, maybe I should say x0, y0, z0. I move a little bit from this point in x, y, and z directions. What is the result? Well, this is just u of x0, y0, z0. Of course, this is approximately plus u sub x, x0, y0, z0, delta x, plus u sub y, x0, y0, z0, delta y, plus u sub z, x0, y0, z0, delta z. So if you move a little bit in x direction, x, y, z direction, this point, the u coordinate is changed this much. Similarly, v coordinate will change a little bit. So it will be v x0, y0, z0, and then v sub x, Let me just write it like this: delta x, v sub y, delta y, and v sub z, delta z. And similarly, w, okay, so w x0, y0, z0 plus w sub x, delta x, w sub y, delta y, w sub z, delta z. So this means what? If I increase x coordinate delta x unit, but uh, keep delta y and delta z equals 0, then UVZ, UVW coordinates are changed how much? U coordinate is increased this much because delta y is 0, delta z is 0. V coordinate is increased this much and W coordinate is increased this much. So this will correspond to the vector A, which is, so V coordinate, so U coordinate is this, has changed this much, and then I have this, and then W x0, y0, z0, all is multiplied with delta x. Okay, so A is this vector. A is this vector. Okay. What about B? Delta y gives me the vector B. So this time I increase y but doesn't change x and z. Then we get what? U sub y, v sub y, and then w sub y, and this is multiplied with delta y, and delta z gives me this vector u sub z, v sub z, and w sub z, delta z. So volume is changed how much? dv, which was delta x, delta y, delta z, is changed to what? The volume of the parallel pipette. What is the volume of this parallel pipette? What is the volume of this object? Volume. Well, if you have three vectors forming a parallel pipette, what was the volume? Volume is the determinant. Which determinant? You write the vector A here, B here, and C here as your row of a matrix. Şöyle yazayım. Okay, it is just the determinant of the matrix. You write A here, B here, and C here, and you take the determinant. That's the volume. Değil mi? 3 tane vektörünüz bir paralel pipet verirse uzayda, onun volume'u şöyle de düşünebilirsiniz. B ile C'nin cross product'ını alıyorsunuz. Bu base area'yı veriyor. A'de height vektörü, onunla dot product alıyorsunuz, değil mi? Bunun anlamı şeydi. You take the cross product of these two and take dot product with this one. So that's the volume. So I just need to compute this determinant, change to, so it is A dot product with B cross C. So that's the determinant of A. A is what? A is the vector U sub x, V sub x, W sub x times delta x. Of course, I have here delta x with delta x, x, and then the vector B is just u sub y delta y, v sub y delta y, w sub y delta y, and then w no u sub z delta z, u sub v sub z delta z, and w sub z delta z. And what is the determinant of this? Well, delta x goes out, delta y goes out, and delta z goes out, and then you have this determinant. U sub x, v sub x, w sub x, u sub y, v sub y, w sub y, u sub z, v sub z, w sub z, computed at the point x0, y0, z0. Okay, so this volume, it was delta x, delta y, delta z. It is changed to this thing. So this thing is multiplied with this determinant. Okay, this determinant u sub x v, okay, u sub x, v sub x, w sub x, u sub y, v sub y, w sub y, u sub z, v sub z, w sub z. Bunu şöyle de yazıyoruz. This is also denoted like this. U, v, w, and then you take x, y, z, is called the Jacobian determinant. Belki şuruna şöyle yazmak lazım. Determinant olduğunu. Determinant of u, v, w with respect to x, y, z. Okay. İki değişkende olduğu gibi is in the case of dolayısıyla hence we have this. Hence if we have an integral, okay, of some region in the x, y, z plane, let's say f of x, y, z dv, or f x, y, z, let's say dx, dy, dz in the r x, y, z plane region. You write this in u, v, w coordinate system, and you replace your x, y, z with g, u, v, w, and then here you have your Jacobian okay, x, y, z, no, evet, Jacobian'la çarpıyoruz. Tamam. U, v, w, x, y, z, and then you have du, dv, dw. Okay, where this g, u, v, w is nothing but f. It was f of x, y, z, but each variable is a function of u, v, and w. So I just take composition. Okay. So the idea, here is the same as what we had done for two variable functions. Okay, it is nothing different than that. Let me do some examples. Uh, for example, let's look at burada bir remark olarak da şunu yapayım. Remark. Şimdi x is a function of u v w, y is a function of u v w, and z is a function of u v w. And thus, if this is a coordinate transformation, I can write u v w in terms of x, v, and x, y, and z. So I have also this x, y, z, and w is a function of x, y, z. And I may consider the following Jacobians. Jacobian of x, y, z with respect to u, v, w. This is a matrix, and the determinant of this, as usual, just determinant of this x, no, u, v, w, x, y, z, but you need to take inverse of it. Yani değişkenleri ters sırada yazarsanız bu da anlamlı tabii. Bir yerden bir yere geçerken mesela if you multiply volume by 5, so in the reverse direction you have to divide by 5. Okay? This is what it tells. So passing from one coordinate system to another coordinate system at the point, if you are multiplying the volume element by a number, if you go in the reverse direction, you have to just divide by that number. This is exactly what it says. Okay? Let's do some examples of coordinate transformations. The first one is cylindrical coordinates. So in the x, y, z coordinate system, we have the following. Okay, suppose we have a point x, y, z. We look at its projection onto the xy plane. So it is x comma y comma 0. And then we have, okay, let me just mark the coordinates x, y. This is y. And z is okay here. What are the cylindrical coordinates? I consider the vector joining origin to the point, call its length r, and theta is the angle here measured from the positive x-axis to this vector rotating counterclockwise. And I think I had done this before. So what are the x, y, z coordinates in r and theta? And of course, there's also the z coordinate. Bu noktanın bir de z koordinatı var tabii ki. So I don't touch the z coordinate, but the xy coordinate are transferred into polar coordinates. So we have the following transformation. I have x, y, z in polar coordinates, Cartesian coordinates. In polar coordinates, we have r theta, and z. We don't touch z, only replace x and y with r and theta. And what are the transformations? What is x, for example? X is, of course, just r times cosine theta, as usual. Y is r times sine theta. And, of course, z is just z. Okay? And similarly, what is r? R is just x squared plus y squared square root. And what is theta? Well, it is just tangent inverse y over x, as usual. So these are the coordinate transformation formulas. What is the Jacobian? So dx, dy, dz in terms of r theta and y. So that will be the determinant of the Jacobian x, y, z with respect to r, theta, and z. And then I will have dr, d theta, dz. Okay. Bir dakika, burada şeyi yanlış yapmayayım da şimdi bir birim uzunluğu 2 birim uzunluğa çıkartıyorsa o zaman buraya, değil mi? Burada 1'in integralini alıyorsam burada 1 bölü 2'nin integralini almam lazım. Okey. Değil mi? İntegrallerin eşit olması için. Dolayısıyla da Jacobian UVW şey neyse bunun tersiyle çarpmam lazım. So I have to put minus here. Okay, I have to be careful, yeah. Yani minus koyduğunuz zaman da bu şey olacak. Tabii ki, yeah, I have to be careful. This is just the Jacobian of x, y, z into UVW, right? Yani fikir şu. Koordinat transformations diyelim ki uzunlukları 2 katına çıkartıyor. Aynı fonksiyonu integre ederseniz cevap 2 katına çıkacak. Çünkü mesafeleri 2 ile çarpıyorsunuz. O yüzden bunu kompanse etmek için bu 1 birimi 2'ye çıktıysa bunun önüne 1 bölü 2 koyuyorsunuz. Yani alan ne kadar büyüdüyse, hacim ne kadar büyüdüyse ona bölmeniz lazım. Alan ne kadar büyümüştü? Bu ifade kadar büyüyordu. O zaman bunun tersiyle çarpıyorum. Bunun tersi demek de x, y, z'nin u, v, w'ye göre Jacobian'ı. Tabii şuradakini de kontrol edeyim. Onu da yanlış yazdım muhtemelen. Yani hesapları doğru yaptık da orada şeyi karıştırmış olabilirim. Evet. Bu area böyle transform ediyor ama integrali yazarken I have to take negative of this. Okay, yeah. Tamam, bunu doğru yapmışız da sadece orada şeyi yanlış yapmışım. Okay. Alright. Alright, so let's write that down. So x is r cos theta, y is r sine theta, z is z. So what is this determinant? Del x y z over del r theta z. So this matrix is this. X, Y, Z'nin R theta Z'ye göre türevi. Derivative of this with respect to R is just cos theta. Derivative of this with respect to theta is minus R sine theta. Derivative of X with respect to, yani bunu şöyle yazayım isterseniz. X R, X theta, X Z, Y R, Y theta, Y, yok böyle yazmamıştık ya. Şöyle yazdık değil mi? X, Y, Y, R, Z, R yazdım. Ama fark etmez. Yani R'ye göre türev. E, yani bu determinantlar aynı. Şöyle yazayım ben. Y, R, Y theta, Y, Z. Z, R, Z theta, Z, Z. Benim yazdığım bunun transpozunun determinantı, ama o ikisi aynı şey. Aynı şey, fark etmez. Yani bunun transpozunu alıp determinantı alırsanız da aynı şey elde edersiniz. So what is this? Derivative with respect to r is just cos theta minus r sine theta. Derivative with respect to z is 0. Derivative of y with respect to r is sine theta r cos theta and then 0. And then derivative with respect to r. There is no r here, 0, 0. Derivative of z with respect to z is just z. Therefore, the dx, dy, dz is just determinant of this expression x, y, z with respect to r theta z times dr d theta dz. And what is that determinant? Burası 1 olduğu için şunun determinantıyla 1'in çarpımı. Bunun determinantı da nedir? R cosine squared theta plus R sine squared theta dr d theta dz. So this is just R times dr d theta dz. Okay. So if you have a region in xyz plane of some function of xyz, and then here let's say you have dy dz dx dy dz, then this is transferred into r theta z region, and here you have to write xyz in terms of r cos theta, r sine theta, z, and then instead of this you write r times dr d theta dz. Okay. Let me do maybe one example. Okay. All right. Compute this integral x squared plus y squared dv, where d is the region in the first octant bounded by the cylinders x squared plus y squared is 1 and x squared plus y squared is equal to 4, and the planes z equals 0, z equals 1, x is 0 and x equals y. Yani şu x, y, z, iki tane silindir var. Silindirin birisinin yarıçapı 1, diğerininki 2. X eşittir 0, z eşittir 0, z eşittir 1, x eşittir 0. Yani şey demek, bu duvarı alıyorum, bunu alıyorum. Bir de yukarıda z eşittir 1 plane'ini alacağım. Bir de x eşittir y doğrusu var. Yani şu. O zaman region şöyle bir şey. So the region is this. The base of the region is this gadget, and then you just go 1 unit, okay, like this, and okay, şöyle diyeyim. Okay, this solid object. So you have two concentric cylinders, and you have a portion between those cylinders bounded by the coordinate planes. And you would like to compute this integral over this region D. So this is a region in XYZ plane. I can write this in the Cartesian coordinates. Well, clearly Z is ranging between 0 and 1. Pardon. But maybe before Z. What is R? R is ranging between, so if you choose a point here, başka renk seçeyim. Mavi. If you choose a point here, R coordinate ranges from where to where? It ranges from this point up to this point. So R is ranging between 0 and not 0. 1 and 2, right? This is radius 1, this is radius 2. What about theta? Theta is the angle measured from x-axis, positive x-axis. Theta is ranging from where to where? Theta is ranging from Pardon. Yanlış yaptım. Theta is ranging from this angle up to this angle. So theta is ranging from pi over 4, değil mi? 45'ten 90'a kadar. So it is ranging from 0 to not 0. Pi over 4 to pi over 2. Right? 45'ten 90'a kadar. And z is ranging from 0 up to 1. Because at the top I have the plane z equals 1. And at the bottom I have z equals 0. So the integral is what? So d of neydi fonksiyon? X kare artı y kare. X squared plus y squared dv. This is in, so dx, y, z. I write r theta z. X squared plus y squared, well, that is just r squared. And then I have dv. What is dv? This is dx, dy. Şöyle yazayım. This is r x squared plus y squared dx, dy, dz. We write it this way in the r, şöyle yapayım. In the dx, y, z, r theta z. X squared plus y squared is just r squared. Dx, dy, dz, it will be Jacobian, which is r times dr, d theta, dz. And so z is ranging from 0 to 1, r is ranging from 1 to 2, and theta is ranging from 0 to 2 pi. I have r cubed dr, d theta, dz. Or I write it this way, first with respect to theta, and then r, and then z. Okay? Integral with respect to theta is just theta, 0 to 1, 1 to 2. So r cubed theta and 0 to 2 pi dr, dz. Well, that is just 2 pi, so 2 pi goes out, 0 to 1, 1 to 2, r cubed dr, dz. Integral of r cubed is r to the 4 over 4. Oops. Ee, Yok. Bunu yapmayacağım. Fazla hızlı yazdım herhalde. Eyvah eyvah. Okay. Evet, onu lost etti. Okay, I'll go over that. Well, hopefully it's in the video. I'll watch the video, write the notes, and write the last line. Let me stop here. Geri kalanı sanırım yapabilirsiniz, değil mi? Ben gerçi notları tamamlayacağım. Ben hepsini kaybetmedi. Okay, let me stop